I want to have a AI lawyer that can do everything for me. But in reality, what you probably need to do is start with smaller constrained tasks and then build up those capabilities and string them together to be able to get to that end point of a lawyer that can do XYZ and get hyper specialized on document parsing for that type of legal aspect. Once it gets good at that, expand the capabilities until you get to a point where you have a full-on AI lawyer, similarly to the approach of self-driving cars, where you first get the capability of parking, you first get the capability of driving on the highway, you next get the capabilities of driving on roads where there's not snow in a city and not around school children. And you get those different capabilities and then string them together to eventually get to that point.
Welcome to AI Catch Up, the podcast catching up with the tech products that matter in the AI era.
Hi everyone, and welcome to the AI Catch Up. This is the podcast where we are revealing the stories of AI builders and startup founders, and we are looking behind the scene. Today, I'm joined by Nico Finelli, and he's a founding DTM at Vellum.ai, who has already done an impressive job in the research space with self-driving cars. He has been working with lots of different teams at Weights and Biases, and now he is building the LLM orchestration platform at Vellum.ai. Nico, welcome to the show. Very glad to have you.
Excited to be here.
I would start with one of the previous places that you have been working at, Biases. You have seen different ML teams, and that was before the ChatGPT wave. There were many different iterations that teams have already been going through. Vellum has started already after the beginning of this wave, and that is why I would be very curious to hear what patterns you have observed when it comes to different teams being successful at implementing new features, and at the same time, what was your, aha moment for, yes, that is the time for us to kick it off with Vellum.ai?
Yeah, absolutely. For people who are unfamiliar with what W&B does, is they're an ML ops platform for all of the foundation model builders or any ML team that is doing cutting edge research to track the epochs and iterations of the models that they're working on and have clear insights into what they're building. A lot of the teams that I worked closely with at Weights and Biases were teams like Hugging Face or Midjourney. The Hugging Face experience was probably the one that was of the most interest to me and led me to go and join Vellum. So a lot of the things that they were working on at Hugging Face is they were evaluating how these open source models were actually performing. What they were doing, and it's kind of like an industry standard, but way to think about it, is they were using the term vibe check very frequently about how well these were performing by going in and doing human evaluations of how the models were performing on specific different tasks. This was post ChatGPT, as you mentioned, at this time point, and kind of the aha moment for me about what Vellum was doing and how it was going to apply across the broader business sphere was the aspect of you have a very experienced cutting edge research team that is going about this process in this way. And you'd have to imagine that the teams at different business organizations are probably going to have even a less degree of intelligence when approaching these different situations. So they are going to have even more troubles when they're trying to do prompt iterations, when they're trying to select their different models, all of those types of aspects. And at Weights and Biases, the real value, in my opinion, was for companies that were either building their own foundation models or doing explicit fine-tuning of these models to get better outputs. But from what I gathered and my theory of how these were going to evolve, and it seemed to take in that pattern, is prompt engineering, chaining, and the orchestration around utilizing these LLMs is going to be where a lot of the value is currently for these organizations. When you're doing that, there's a lot of issues that arise around that, and most of them come down to the evaluation process and making sure that the orchestration of these specific prompts and the chains themselves are being executed appropriately. Some of them being there are relatively small amounts of teams actually building foundation models or doing fine-tuning. So the market there is much more concentrated, even though their probable willingness to spend is going to be very high. And you can see that with the huge boom in the NVIDIA stock price, all of these companies that are building the foundation models raising boatloads of money. But if you look at the TAM, or the total addressable market, of every other company that is going to have to start leveraging these LLMs, it's absolutely enormous, because it's anyone that's building with software. So anyone who wants to start adopting these LLMs, it's going to be a very large market there. And they're going to have issues because they probably don't have a very robust research team that's going to be attacking these types of problems. So one point of clarification I would want to mention is I joined Vellum about a year after it was founded, but definitely very much agree with the kind of thoughts and principles that went around it. And most of the thoughts and principles are, this needs to be a test-driven development process for anyone who's integrating LLMs into an MVP, or actually eventually into a production sense. And the rationale behind that is people are wary of putting AI systems in because they're non-deterministic. So they need to have a robust testing framework and the ability to roll back to previous models or iterations if they start performing as not intended, as well as being able to iterate on prompts or models very quickly, because the foundation teams are pushing out new models at a very frequent pace. The aha moment for me is twofold. The addressable market was extraordinarily large. Even the top of the end research teams were struggling with this, meaning that all of the teams that have presumably less talent are going to struggle even further. And there wasn't a lot of frameworks or abilities out there, either in open source or in paid platforms, to be able to help assist these teams as they're going into this new age of building.
Yeah, just one point that I'm reflecting on is what you have previously mentioned was vibe check. At Hugging Face, vibe means something that is working in machine learning space and something that is very efficient. The main models, the main data sets are getting on top of Hugging Face leaderboards. At the same time, based on certain criteria, we can probably also evaluate certain interesting, let's call them insight points when it comes to medicine or a legal field. And that would be the vibe check that is also happening in the domain expertise, right?
Yes, so that's kind of another aspect that we found in building out our platform is a lot of our early adopters and a lot of customers who came to us with a very direct need right off the bat came from spaces where you needed a lot of subject expertise. So specifically the medical field and the legal field, because that's something where you have to have a very rich understanding of the domain that you're working in. And typically you're not going to find a software engineer or a machine learning engineer who's also a practicing lawyer or doctor. So being able to evaluate those outcomes from an LLM are going to be much more difficult. So going through the manual evaluation process in that way becomes a lot more difficult. So you almost need a platform in those cases to be able to integrate with that allows those domain experts to come in and help with the evaluation process.
Very interesting. And what I also recall from one of our prior conversations that, as far as I recall, was even happening before the DeepSeek moment and the review of the whole reinforcement learning, you have been mentioning that, well, we are building AI agents with certain supervised approaches in mind. At the same time, back in App City, you have been already looking into how to make autonomous vehicles safer. And then your statement was that, well, we should be building AI agents similarly to how we are building self-driving cars. Would you say that that is indeed the aspect that we are overlooking right now when we are creating AI agents?
Yeah, so I went to the University of Michigan and did some work at Tech Lab, which is a part of City, which is the University of Michigan's autonomous vehicle proving grounds. So a lot of my time in university was spent thinking about autonomous vehicles, how that's going to impact the world, what actually got me interested in machine learning originally. Coming back to your points about the parallelism that I'm seeing in the autonomous vehicle sector to what we're seeing in LLM development right now is the idea that people are looking a little bit too far into the future of how these are going to be impacted and not figuring out how we're going to step to eventually either full self-driving or these AGI agents, which is a relatively complex idea in general about what AGI is itself. But one of the ways that I like to think about the autonomous driving aspect and then compare it back to where we're at in LLM development is, when AlexNet dropped, a lot of people said, we're a couple years away from full self-driving cars. But in reality of how that actually came to be, we didn't just come out and unleash a full self-driving car to just go out on the roads. The approaches that we saw that were working relatively well was we constrained the problems there to be able to work on different piecemeal approach. People are probably familiar with Tesla's autopilot that only worked on highway driving with human supervision. There was a lot of other very interesting companies out there. One of them that I worked with at M-City was called May Mobility. And what they focused on was very much last mile approach. So you can almost think of it as a shuttle system or a bus system where it has a specified route where it might start at a parking garage and drive to a office buildings like front doors where it could be a couple miles separated from that. One of the interesting aspects of that is you can reduce a lot of the constraints and possible harm that could happen in that approach. So in that May Mobility case, they were not choosing paths which were going to have crossroads where school children might be going to school, or they'd be going to areas where if they know there's construction on that road, they're probably going to route against that. And because they're able to constrain a lot of those complex variables, the solution of self-driving in those situations becomes a lot more attainable or a lot easier. And then even if we take that a step lower, there is a lot of ability to start at an easier problem and then piece those together to get to a solution. So if you remember cruise control, the first thing that started to happen in cruise control, even before lane assist, was the ability to have a sensor on the front of the car that would control cruise control, but if it had a sensor and you got too close to the car in front of you, it would slow down for you. And those are a lot of the core capabilities that are eventually going to lead to full self-driving cars. And I think a lot of people, when they're thinking about LLM development in business applications, aren't taking that same approach, where they're looking at, okay, I want to have a AI lawyer that can do everything for me. But in reality, what you probably need to do is start with smaller constrained tasks and then build up those capabilities and string them together to be able to get to that end point of a lawyer that can do XYZ. Start with something like tort law and get hyper specialized on document parsing for that type of legal aspect. Once it gets good at that, expand the capabilities until you get to a point where you have a full-on AI lawyer, similarly to the approach of self-driving cars, where you first get the capability of parking, you first get the capability of driving on the highway, you next get the capabilities of driving on roads where there's not snow in a city and not around school children. And you get those different capabilities and then string them together to eventually get to that point. And I think a lot of people are looking at it too far into the future and not thinking about how do I collect kind of these abilities for my own business use case in a smaller sense to expand the constraints that are required to get to something that's actually extraordinarily beneficial.
So if I would be thinking about more practical examples that you have already referred to and the process of building this AI lawyer agent, I should imagine that we could consider to take all the conversations from very, very experienced lawyer and then train the system to act similarly to how the examples are. What you are suggesting is that it would be better for us to consider a certain field in the legal matters and then get good at it. What the question for me would be is, well, how does the reward function might look like? And if I would be also thinking about a small team implementing this type of agent, how they can, from the practical perspective, define that for them, taking into account both aspects of evaluating how good looks like, but also how to orchestrate the feedback loops, and also something as expansion of certain areas that this agent is focusing its effort on.
Yeah, and you bring up a really interesting aspect of the reward function. When you're talking about LLM applications in the business setting, that reward function is often very specific to the type of business use case that it's going to be associated with. If you're talking about something in the legal space or the healthcare space, it's probably up to the domain experts to understand that reward function, because I personally don't know what it means if you're going to misdiagnose something in a healthcare setting. If you misdiagnose something in, let's say, the case of a cancer diagnosis, that could potentially be life-threatening in that situation. But if I misdiagnose something like the common cold, what is the actual impact of that? I don't know. And that's going to be use case to use case. So this is coming back to the idea of constraining your problems to start with the lowest possible impact, so the reward function doesn't have to be as extreme. And then once you get good at that niche where the possible negative outcomes are lower, then you start to expand to those consequences being higher and higher. And that's the aspect of the self-driving thing. It's pretty standard across the board of, if you hit a pedestrian, if you hit someone on a bike, anything like that, that could potentially be fatal. So you want to try to minimize as many interactions with them as possible. But in the business use cases, it goes across so much. It's really hard to try to quantify what the negative aspects are. So building a reward system around that to say, hey, maybe it's just anything that's in this area we don't touch until we feel competent to go and start navigating that area.
Yeah, it does make sense. And it is rather fascinating to think that the process of teaching machines can and very likely will be more efficient if we are defining the task at hand based on something to avoid rather than defining what the right answer is. And I would be also curious to think how you are going through the process of defining that together with the customers at Vellum. Could you walk us through a certain a case study?
Yeah, a lot of our initial adopters came from the healthcare space, and a lot of them are doing things like scribe technology. So one of our customers is DeepScribe. What they do is they're building software where your doctor comes in, they have some recording device like their phone or some other recording application within there. The doctor and the patient have an entire conversation. What that does is then takes that entire conversation, turns it into text, and then from there, they're using LLMs to take that conversation and then import it into their EHR or their electronic healthcare records within there. So what that process then does is doctors spend about 30 to 40% of their day going in, taking notes, and then having to follow up with those patients, all of that type of typical process. So in that sense, what they're doing is just, it's a note-taking application, but it's scribing those out for them. The process that typically happens for our customers is in that scribe process is it goes in, parses out the relevant information, might turn it into SOAP notes, things like that. And then on those companies, they typically have doctors who go in and then validate that the records were appropriately transcribed. And it potentially, in some cases, will then offer recommendations of what they think based on the conversation and the patient's health records could be possible outcomes. Right now, all of that is still being done by doctors, but it's just as potential inputs. So it relatively mitigates the negative outcomes of LLMs trying to do these processes on their own. And then on top of that, when it's doing those summaries, you have doctors going through and manually indicating whether the summarization was good and bad. So the process would be, it records it, puts it into the EHR system, and then you can implicitly understand how well the LLM did at the summarization, because in those text fields, the doctor either will just accept what the LLM created for the summarization and input into the notes. Or if the doctor edits it, you can then take that response and say, this is an area where we're potentially not doing so well, and could go back, try new models, try new prompting techniques until you get to a point where you're reaching a threshold of accuracy that you're comfortable with.
I love how clear the almost binary evaluation works in this sense. It is either correct transcription or not correct transcription. What I have also heard from radiologists when I have been analyzing the field of cancer, and I have been looking into how to bring the AI assistants to the applications of radiologists. And here should probably come the meme in the visual version of the podcast, was radiologists still going to work in their normal cars and not self-driven cars, and still transcribing everything using very traditional typing, not even transcription techniques, unfortunately. I've seen how the experience of Vellum has been very well described on the website blog, so I would definitely recommend our listeners also to check it out. There are interesting case studies and very practical descriptions of how certain processes can be represented in AI applications. And this year you have released the State of AI report. And as far as I recall, there were 1,250 AI developers that were being interviewed on how the process of building AI applications is going for them. And we do have already, well, one could say 2-3 years of rather extensive experience gathering in the field. So what surprising things have you learned from that report?
Yeah, so I wouldn't say they're extraordinarily surprising to me, having worked in the space for quite a while. But the one thing that I would want to highlight from that report is while AI is getting all of this buzz, from that report itself, we found out that about 25% of the respondents of those 2,500 responses within there are actually getting to production. So only a quarter of teams are getting to production. There's probably like a plethora of reasons and rationale behind that. Alluding to the previous conversation, a lot of that probably has to do is the MVPs of the aspects or the things that they're trying to build on are probably too wide in scope. So when they're doing the cost benefit analysis of, do we want to put this in? The potential harm that could be done to their brand is relatively high. I think when LLMs first got the big stage, we all heard about those specific things like Air Canada having to pay those refunds because the chatbot said that they would, and people were getting a little bit more sophisticated in prompt injections. So people had to roll back their approach and say, hey, we need to put in more robust guardrails. We need to scope down what we're going to be having AI to do to build up those competencies and muscles before rolling it out on more aggressive projects around that. And in addition to that, of the teams that I've seen get to production, the biggest gap is typically around that evaluation process. So teams who are really good at evaluating their AI systems and both doing unit testing on the individual prompts that they're working on and the entire workflow itself and evaluating those entire workflows. Teams that have a very fast iteration cycle in testing those and a large set of data to test on are typically those who are actually getting to production. And I think that's the big insight that I saw, as well as all sorts of other stuff that's just interesting in the market of OpenAI dropping in usage in comparison to Anthropic or open source solutions. But in terms of actionable insights for the listeners, I think the biggest aspect is understanding how to set up your evaluation framework to get to a point where you can get value out of your AI system.
And if I would think about a startup of 10 people working on a certain task, what evaluation aspects should they take into account? Especially since I think that we both would relate to the feeling that if you are creating an AI application, you would like to first get it going, right? And then once it works, then you think, oh yeah, and then I will take care of everything else. So at what point should this team of 10 folks start thinking about evaluations, and how would you recommend them step-by-step approach this? On what stage and with what types of evaluations?
Yeah. So there's a wide aspects of how you could take this approach. It really all comes back to all that I was saying at the beginning of what are the potential ramifications if the AI system is incorrect, and what level of human oversight are you going to have? For most cases in the medical field, I'd recommend approach probably similar to this, where you start with an MVP. You have a goal of a minimum competency from whatever agent that you're building within there. Once you feel okay about it, what I would probably say is you roll it out in an MVP where it's not actually making any decisions themselves and has full human oversight. From there, what you would do is go into a data collection mode where you have the AI system doing whatever task it's doing, and then having a human reviewing that information that they were already going to do themselves. And the kind of key aspect is when you're building these systems, you want to have that full information capture happening at each process where you're trying to experiment with different combinations. You have maybe some sort of manual evaluation from data that you labeled prior to the rollout. You're doing the A/B testing of those experiments in the system live with human oversight. So I wouldn't say it's in production in the sense that it's reaching the end customer, but you're doing testing on that. And then you're monitoring that entire solution from there with the feedback captured by the user who would be doing that process themselves. So let's go into the healthcare situation to the aspect of the EHR system, where you start with something. It doesn't have to be very good to start with, but you probably don't have a ton of fantastic labeled data to start with. You build with the base system. You then go in, use it to help augment the doctors, and the doctors then go in and review. And the big thing is getting that feedback from the user to then help with the next iteration where you can evaluate on that. In this case, it's pretty clear of that implicit or explicit feedback. Either they take it or they don't. And you can use that kind of framework across a lot of different ideas. It's use case to use case about what that implicit or explicit feedback would be. But once you capture that, you can then use a plethora of different techniques, like semantic similarity of the output, using rules-based approach in your evaluation on the next iteration, and then collecting all of that data and having those metrics associated with it. So that way your evaluation process becomes a lot more quantifiable and moves further away from this idea of a vibe check, because you have a hard science approach of, is it getting to an outcome that these experts in the domain would agree with?
Thinking about how to represent the functionality that you have learned based on the examples and different companies that Vellum has worked with so far, you have definitely put some thoughts also into how to design the SDK for Vellum. Maybe you could walk us through the latest release and how it supports AI developers on the evaluation, how it goes through various stages that applications that are powered by LLMs normally go through, and what are the things that people who try Vellum SDK could expect?
Prior to the SDK launch, Vellum was a UI-based SaaS application. And one of the major goals of that was to allow the subject matter experts to be a part of the prompt engineering in the evaluation process as it went through. So that way they did not have to go into the GitHub repos or code base to be able to make edits to prompts. So what the Workflows SDK product that we've launched is the ability to pull down and push whatever workflows that you're building from the UI down into fully executable Python. And one of the big processes and thoughts around that was to give developers full access to all of the building blocks that we've already put into the application to make it as customizable as possible and reduce the potential aspect of not being able to build for your specific use case that you want. And a big portion of that we thought about was agentic behavior as we believe that that's going to be a huge fundamental aspect of this next year in terms of LLM development. And coming back to the autonomous car analogy that we've been using is we think about that in multiple different aspects. In autonomous driving, you have L0 to L5. The L5 is the fully autonomous agents. Similar framework where we think about the basic LLM call is like L0. L1 is the use of tools where you might have a function call or an API call within there. L2 would be a reasoner where you might have an LLM that does some planning. It observes something through like a web scrape, something like that, and then it takes action and actually does an output within there. L3 would be an operator that's kind of fully autonomous and could be kicked off. And then an L4 would be more of traditional AGI where it's creating its own function calls, it's writing its own code that it could then run. And a big prioritization in the SDK was making it at such a low level that all of those possibilities are very capable in doing so. So that way developers can take this in any approach that they want, depending on how capable their team is within there, as well as just taking out a lot of those thoughts that you might need to in things like managing state, parallelization, all of those complexities that you typically would have to think of if you're building this entirely in your own custom Python execution.
Sounds great, especially great from the perspective that certain procedures are already handled for you. And when it comes to handling complex operations and also things where we should hand over from one component to another, I'm definitely having a hard time on understanding how multi-agent systems would actually work. Will we end up having graphs that would be interacting with each other? Will we indeed try to have certain rule-based systems? Will we have, hierarchical systems? What is your take on that and how we could come out of one self-driving car to maybe jumping between self-driving train to self-driving ship and then, I don't know, let's say the yacht in the end. Why not?
Yeah, so I mean, kind of coming back to these like multi-agent approaches, the way that I think that these like fully autonomous systems are going to be built is very similar to that autonomous driving aspect, where you might start with lower level components. So again, back to you have a car that can parallel park for you. That's going to be something that is absolutely required if you want a car that can drive in a very tight city space. To be able to drive in, from Chicago to LA, you need to both be able to navigate the city, you navigate the highway, you need to do that entire process. It's probably, for these multi-agent approaches, going to be similar based on what I'm imagining the world will look like. You're going to have different components of an agent that start with really small constrained possibilities. So in the case of a lawyer, it's going to be able to analyze certain types of documents really well, and that turns into a tool that it can then access. And this first agent is probably just going to turn into a router to determine which other agents it needs to call and reply or rely on, and just add additional tools to it. And then the eventual end state would be the ability to write code to think on the fly of none of my agents can help with this. How would I plan and do this? Tap on a human to say, is this reasonable? Or potentially guardrails that say, don't touch anything that's in here, say that you need help in this aspect. But that's my thought process is this piecemeal approach where you get capabilities in different aspects. And as you bring them together, you can approach harder and harder problems. And that's how I think about this agentic building that's going to be the future.
Divide and conquer. That has
Absolutely.
been the reason for the success of the phrase, right? I should share that you have definitely encouraged me on thinking about building AI applications from the outcome-driven perspective. Is there something as your message to the listeners that you would like to live with? What would you encourage people to think about when they are on the iterative process of improving their AI products?
I think the biggest thing is a lot of people theorize a lot about how AI is going to impact the world. At the end of the day, It's just become so easy for anyone to go out and build something themselves. So I think the biggest thing is go out there, build something yourselves. And then if you can use the kind of test driven development process to capture feedback and get your iteration cycle as short as possible, it's easier than ever to actually build something that can have a pretty profound impact on whatever you're doing, as big or small. If it's something as small as just building a small personal agent that is going to schedule dinners for you, like it's pretty easy to do that. And the negative consequences or impacts of that are relatively low. But that's probably the biggest thing is just it's so easy to build things now. Just go out and start doing it and build competencies in the low consequence areas. And from there, sky's the limit.
Sounds very energizing and exciting to hear that. Where should listeners actually contact you when it comes to them right now dropping the dinner scheduler GitHub repositories? What is the platform of your choice that you like to be contacted?
Yeah, for me personally, it's definitely through LinkedIn. I'm not very active on most of my other social media accounts. So either LinkedIn or you can just reach out directly to me at Nico at Vellum.ai over email. But yeah, that's probably the best way to get in contact with me.
Sounds great. Thanks a lot for your time.
Yeah, thank you so much for having me, Elena.
AI catch-up brings the news. Tech solutions users can't refuse.